Hey, Kenai Middle, 7th grade. Welcome to another quick lesson. So this is going to be a continuation of Chapter 2, Section 3. If it's in red in here, you're going to put that in your science notebook. Okay, here's today's goals. Number 1, learn and describe what carbohydrates are made of. 2, describe that not all carbohydrates are the same. 3, learn that not all sugars are the same. And 4, be able to describe what a chemical bond is and what happens when they get broken. Alright, nothing's in red, just a quick refresher. So quick question, who is the smallest cell, atom, organism, or molecule? Hopefully you picked atom. So atom are these little invisible building blocks. You put those together, you can start to make molecules. Start putting molecules together, you can make things like cells, and then you can make things like organisms. Remember these? The big 6 elements of life. Nothing's in red. We already have this in our notes. Just a refresh. Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. So over here on the right side of your periodic table of elements, that's where they live. Hydrogen is in the top left. Don't worry why he's there. But again, if you start hooking these together, these atoms together, you start making molecules. Molecules can be very simple, or they can be very, very long and complex. Ooh, remember this? Okay, this is some science lingo that's going to make your life easier, I promise. Monomers, think of those as like one, the word mono. If you've heard mono e mono for basketball, one-on-one. So monomers are like individual building blocks. Polymers means many. So if you take monomers, string them together with bonds, you make a polymer. That process is called polymerization. Alright, so now we are in red. We are Chapter 2, Section 3 continued. Carbohydrates. Carbohydrates, they are made of sugars. That's the first thing that we are going to put for those. So sugars are the building blocks. So if you look at this little picture right here, alright, this is coming out of an apple. Boy, this is quite a thing going on here, isn't it? All I care about is that you see, look at our big 6. There's oxygens, there's hydrogens, there's carbons. These little lines here represent chemical bonds, and you can see they're in different angles, and that is on purpose. Don't worry about the angles of that stuff. Just know our big 6 are in there, and this is a representation of a sugar molecule. Okay, so we know they are made of sugars. There are different types of sugars, and these sugars are the building blocks for carbohydrates. So check this out. Some of you, if you've got someone in your family that has blood sugar problems or diabetes, you're probably familiar with glucose. Maybe you've heard of fructose corn syrup. If you've heard of sucrose, that's like regular table sugar. But what I want you to see out of this little diagram, right? Glucose is a type of sugar. Fructose, that is a type of sugar. These two happen to be bonded together, and when these are bonded together, we made even another type of sugar called sucrose. So you're looking at 3 different types of sugars, all right here. And you eat these, you ingest these into your body. So I want you to get it out of your head that sugar is the white stuff in the bowl that you put in coffee or tea or use to make cookies. That is one type of sugar, but not all sugars are the same. Just like proteins are not all the same. Okay, so we're still on carbohydrates. We said not all carbohydrates are the same because not all sugars are the same. So we have 2 types of carbs. So I'm going to shorten up the word carbohydrate there. So we have simple carbohydrates, 1 or a few sugars linked together. And we have complex carbohydrates. This is lots of sugar molecules linked together, up to hundreds and hundreds of them linked together. And we'll look at some examples of these. So if we go back real quick, okay, here are simple sugars. And that's considered simple. And look at all the different ingredients in there. And all these little sticks right here. Remember, those are chemical bonds. those are considered simple sugars. And they make simple carbohydrates. So if you string hundreds of those together, possibly, it doesn't have to be hundreds, you start making complex carbohydrates. So I got this off the internet for you. Boy, if you search this stuff, there are just so many different visuals. So I tried to find you one that's fairly easy to look at. So I like over here on the left, it says simple. So here you can see your oxygens, hydrogens. These blue spheres in the center, those are going to represent carbons. So there's a simple carbohydrate, and then down here you have an example of a complex one. So you can see that each of these right here is a sugar molecule, and they are bonded together right there with a chemical bond. So simple and complex carbohydrates, your two types of carbos. All right, still going with carbohydrates. They can be used for energy, or they can be used for energy storage. You're going to use carbohydrates for energy. If you had junk food this morning, like a donut, I ate a donut this morning, and it was wonderful. My body is going to break down those sugars for energy. If you're something like a plant, and you are undergoing photosynthesis, you can use your carbohydrates as a plant for energy for yourself. But if you start storing up too much, you need something to do with it, right? So you're going to store it. Just like if you were lucky enough that someone in your family or someone in your group got a moose, you're not going to eat it all in one sitting, right? You're going to store that moose energy in the freezer to be used later. So plants kind of do the same thing. They're going to store energy in carbohydrates. An easy example for that is right down here is starch in something like a potato. So a potato stores its extra carbohydrates as a starch, and so it links all of these sugars, starts making a big long chain of them into a complex carbohydrate, and one of those is a starch. So let's talk about chemical bonds real quick. There's a lot we could learn about chemical bonds, but let's just get the bare basics of this stuff down so we can relate it to things like carbohydrates and proteins. So chemical bonds, for now, just think of them as they're bonds. I mean, what they say they are. So they attach atoms to other atoms. So you could think of it as like a nut and a bolt that hooks something together. You could think of it as like super glue. You could think of it as like a rope if you want to. The bottom line is that it's a bond, so it hooks other atoms together with other atoms. The second bullet, when you break a chemical bond, energy is going to be released. So let's go through this little picture progression down here. Let's start on the bottom left. All right, so here's an oil platform, oil and gas platform. So out in Cook Inlet right now, they're pulling out oil, pulling out natural gas. So let's talk about natural gas, because that's a simple molecule to look at, but it's really cool and really important to our daily lives and our economy. So here's natural gas. We also call it methane. So it's one carbon atom and then 4 hydrogen atoms. So again, these sticks right here, those are representing a chemical bond. So you have 4 chemical bonds in this picture right here. Now what happens is if you take a bunch of these methane molecules, you clean it up so it's pretty much pure methane, and you put it in a pipe and you send it to customers. If you have an ignition source, like on your stovetop, it's going to light this stuff on fire. And so what's happening when you do that is these bonds right here, when there's an ignition source and there's some oxygen available, it's going to start breaking these chemical bonds. And what happens is down here on the bottom right, you get tremendous amounts of energy, in this case in the form of heat, it's released to do all kinds of wonderful things that make our modern lives very comfortable. So take that concept right there of methane and now try and apply it to food. So if you go back and think of a sugar molecule, you saw all those sticks. So let's go right here. Okay. So you could pick the simple or the complex carbohydrate. It doesn't matter. But if you look at all these little sticks right here connecting the dots, those are all chemical bonds. So a simple carbohydrate, so if you ate a donut, it's not going to give you energy for a super long time. There's not too many bonds to be broken. Go down to something complex. So you endurance athletes out there probably know about carbo loading. And look at all of these available bonds that can be broken. It takes your body a lot longer to break these down. So that's more energy available for your body. So still to come, you guys, in section 3 of chapter 2, so 2-3, we still need to talk about lipids and nucleic acids. We'll get to that next time. But here's our main macromolecules. This is all in chapter 2, section 3. We talked about carbohydrates, we talked about proteins. We still got to talk about lipids and nucleic acids. So how do you feel about today's goals at this point? Do you feel you could describe what carbohydrates are made of? So number 1. Number 2, do you think you could describe how not all carbohydrates are the same? Like, how can they be different? And go back and look at those pictures if you want, those diagrams. What about sugars? If you go back and look at those molecular diagrams, those photos off of Google I pulled down, are you able to see that those sugars are not the same? And then lastly, what we just talked about, are you able to describe that chemical bonds hold things together and then they release energy when they get broken? Hopefully you're cool with all this stuff. And if you're not, you can go back and listen again. We do have a quick amount of time, so I'm going to pull this up and we're going to watch this again real quick in case you missed it last week.
Carbohydrates are one of the big 3 macronutrients, along with protein and fat. When you eat carbohydrate, it enters your bloodstream in a form called glucose, which is your body's preferred source of fuel. And your brain, in fact, relies on carbohydrate for energy. Vegetables, fruits, whole grains, and dairy products are some of the best sources of carbohydrates. When people say that carbohydrates are bad or should be avoided, they're usually talking about sugars and refined carbohydrates like white bread, white rice, and noodles. Limiting your intake of sugar and refined carbohydrates is generally a good idea, though, because the calories can add up quickly, and these foods don't offer much in the way of vitamins, minerals, or fiber. But you still want to give your body the carbohydrate that it needs from the better sources.
Okay, so that is it for today. This will be posted on our Google Classroom. And on to our next item on our agenda today.